Hi there, my name is MisterCode, and in this video we're going to talk about how to implement a queue using two stacks. And for this, let's just quickly have a look at what a stack and a queue are, or their characteristics. So a stack is a last in first out data type, for which it holds that the last element that is added to the stack is the one that leaves the stack first, and a queue is a first in first out data type, for which it holds that the first element that is added to the queue is the one that leaves the queue first. So this is of course an important difference. Then the methods of the stack abstract data type are the isEmpty method, which checks whether the stack is empty, of course. Then the size method, which returns the amount of elements that are on the stack. Then the push method, which pushes an element on top of the stack. The pop method, which removes the element that is on top of the stack and returns it. And the peek method, which actually just returns the element but doesn't remove it from the top of the stack. Then the methods that are needed for the queue abstract data type are the isEmpty method, so it again checks whether the queue is empty. The size method, which checks the amount of elements that are in the queue at the moment. The enqueue method, which adds an element at the back of the queue. The dequeue method, which removes the element that is at the front of the queue and returns it. And the front method, which just simply returns the element that is at the front of the queue but doesn't remove it. And in order to implement a queue using two stacks, we have to implement all these methods. So that's what we're going to do in the rest of the video. But let's first explain how we're going to use these two stacks for implementing a queue. Well, the idea in order to implement a queue is to internally reverse the order of the elements of the stack. And we do this by using another stack. So voila, there is another stack. And what we're going to do in order to get from a data type which has as characteristic that it's a last in first out data type to a data type which is first in first out, we're going to reverse this order so that instead of getting the element that is added last, we want to return the element that is added first to the data type. And we're going to use this other stack thus for transferring the elements and then getting, in this case, X at the top, so that we can simply return it. So now that I've explained the general idea, let's actually implement these methods that are needed for the queue. So the isEmpty method and the size method are actually quite simple. So let's just start with these. The isEmpty method can be implemented by simply returning the values of whether stack 1 is empty and whether stack 2 is empty. And this only returns true if both stacks return true, and thus if both stacks are empty. Then the size method is quite simple as well, because we return the size of the first stack and we return the size of the second stack, and we add this together. This amount is equal to the amount of elements that are in the queue. Then let's go to the core of the queue using these two stacks. So actually implementing enqueue and dequeue, and later on of course front. For enqueue we actually simply push an element to the first stack. So let's actually just do that. Let's push element X to stack 1, there we go. Then let's just push some more elements to it that we can use later on for demonstrating the dequeue method. So there we go. Now let's explain the dequeue method. And the dequeue method is relatively the hardest part of implementing a queue using two stacks, because we're going to check whether the second stack is empty. If it is, then we're going to transfer all elements from the first stack to the second stack, and at this moment all elements of stack 1 are on stack 2 but in reverse order, and this actually thus is some kind of a snapshot of the queue where all elements are transferred to stack 2 and which are in the right order when comparing it to how a queue works. And then we're just simply going to remove the element that is on top of stack 2. So in this example we would transfer Z to stack 2, we do the same for Y, we do the same for X, and we're just going to simply pop X of stack 2. And that's the element that was first added to the queue, so we actually also wanted to remove this from the queue first. That satisfies the first in first out property of the queue. But we can also have a look at the situation in which we again add two elements. So let's do that. We add A and B respectively. Well, because we still have a snapshot of the previous queue which contained X, Y, and Z, we still have to, whenever we dequeue, pop these elements first, and then we can again reverse this order, etc., etc., as we will see. So when dequeuing, we will pop Y, then we will pop Z. Then again, when we do another dequeue operation, we have to transfer the current elements to stack 2 again. And then the order is reversed. So B is added and then A is added, and then we return A because it's on top of the stack. So the dequeue method actually works as we want it to work, because it reverses the order if stack 2 is empty, and then it returns the top, and whenever stack 2 isn't empty, we're still popping elements of a snapshot of a previous queue. So this actually works. That's what we wanted, of course. Then let's have a look at the last method that we need to implement, which is front. And this is actually nothing special. It's quite similar to dequeue, because all that's changed here is that instead of popping something of S2, we're going to peek. So we're just simply going to return the element that's on top of stack 2 instead of removing it as well, and therefore front actually returns the element that's at the front of the queue. So now we've implemented all methods that are needed for a queue. So just as a summary, here are all the methods that are needed, and we've all implemented them. So that's it for this video. If you thought this video was useful, make sure to hit the thumbs up, to give it a like. If you still have any questions, make sure to use the comment section, and if you'd like to support this channel, make sure to subscribe. So stay cool. Bye.